Hello, and welcome back to my ongoing coverage of the OceanGate Titan submersible tragedy. With the US Coast Guard's public hearing now well and truly underway, as I stated in a previous video, I will now begin to cover the testimonies given at the hearing, as well as the documentation submitted as evidence by the Coast Guard from their investigation. I just wanted to mention that my original intention with regards to covering the testimonies was to select a few moments from each which were of the highest importance or relevance to what happened to Titan. Things changed, however, when I watched the entirety of this first testimony from former OceanGate Director of Engineering Tony Nissen. If you've watched my previous OceanGate videos, you will know I've covered events and updates regarding the story with a certain degree of depth and thoroughness, and now, well over a year after the disaster, we are finally getting some of the answers that we sought, and also fresh insight from people who were actually there and worked for OceanGate. And, after watching this first testimony, I feel like I would be cutting corners if I omitted certain questions just because of trying to make a video shorter. There is just too much information that can't be ignored. Not only will we, with future testimonies, hear about the key events in Titan's timeline, but also hear about them from different perspectives and from different departments, both inside and outside of the company. One example is the well-known whistleblower David Lockridge, who is named in Tony Nissen's testimony and will also testify himself later on. So I just wanted to explain that that is why I'm covering this hearing in greater depth, rather than the various news channels, for example, who are only posting a few highlights. This does mean a lot of work on my end, as I'm still omitting some questions which do not directly add anything or aren't completely related to the tragedy. Also needed to be edited out are pauses in speech, which I've done to keep the questions and answers flowing, as well as any breaks in the hearing, which needed to be cut, with the first day of the hearing being over 9 hours of footage to go through. But I'm committed to giving the best account of this story that I can on this channel, for my viewers and also for my own understanding. If you are one of my returning viewers or subscribers, I'd just like to thank you sincerely for watching my videos and returning to this channel for your OceanGate updates. If you're not already subscribed and would like to keep updated, please be sure to push that subscribe button. Anyway, enough of my rambling. Let's get into the video. This testimony is from day one of the hearing and, as stated, testifying is Tony Nissen, former OceanGate Director of Engineering.
In what year did you begin working with OceanGate?
March of 2016.
Okay. And in March of 2016, what were you hired on as?
The Director of Engineering.
Okay. And what were your roles and responsibilities in that job as the Director of Engineering?
I was pitched by OceanGate that the Cyclops 2 craft was nearly complete in the sense that all the items were in place. They just needed somebody to take it over the finish line. And they wanted somebody with an extensive marine background. They wanted somebody that was, originally I was going to be the Director of Marine Operations as well. They were having some issues in the marine side, and that's the execution side. So in their mind's eye, I was going to put together the parts and then just start executing it.
What was the vision for the site, for the Titan, and Mr. Rush's vision, as you know it, for the Titan in the future of OceanGate?
Right. This might be hard to believe. When I hired on, I had no idea they planned on going to the Titanic. I was never told that.
What were you told regarding the Titan project at the beginning of your employment? Where did you come into that process at?
They were just going to build a deep sea carbon fiber hulled submersible, and I thought, that's interesting. Okay, like they have a couple of reports that said it's possible. All the items were in place. Really, it was an integration project.
Was there any mention of having this submersible classed or built to a classification standard?
So Stockton would go back and forth on whether or not he was going to have it classed, but the classing conversation was always there and the inspection. And when I came on, it was going to be a much more collaborative effort with either regulatory or classing agencies. And I know throughout the weeks, I think Stockton tried. I don't know any of those conversations, but I know that when we would talk, he would like to have it, or he would have liked to have it done. It seemed like a dead end for him every step of the way.
And I think it's important with your role as the Director of Engineering with regards to Cyclops 1 and to the Titan project to understand the timeline of the University of Washington Applied Physics Lab, which you had mentioned earlier. What was the role of the University of Washington Applied Physics Lab as you knew it as the Director of Engineering?
Dave Dyer was the mechanical representative, so he was a mechanical engineer. He did mechanical systems, so bladders, designs, landing gear, stuff like that. If you had a wire going to it, Dave wasn't your person. Pete Brodsky did controls. And then the operations group really did the primary power, secondary power, battery storage. But for APL, that was it.
And how would you describe the working relationship between the University of Washington Applied Physics Lab and OceanGate?
From my perspective,
Yeah.
Pete Brodsky and I got along well. Pete Brodsky in Stockton, not so much as we got to Titan. Pete wasn't okay with using glass spheres on the outside and decided to remove himself from the project for that reason. And respectfully, Stockton didn't make a big issue of it to Pete at all, but he was mattered and all get out for sure. He was not happy about that because we were losing Pete. And Dave Dyer, if you were the director of operations at the time was Scott Griffith, and then marine operations was Dave Lockridge. That working relationship was great, but it wasn't so great with me. As we got into the June, I think it was June or July, we tested the 1/3 scale to find out where it destructed. So that was that summer. So leading into that, very tumultuous time. So starting about a week or two after I hired on, up until that implosion.
And so the University of Washington Applied Physics Lab said that utilizing glass spheres in the atmosphere on the outside, so not in the pressure hull, was a no starter for them.
For Pete Brodsky, for sure. And you wouldn't put glass spheres in the inside. Well, I guess you could. It'd be overkill. But for the outside, no. And even oil filling them, Pete was not. He was not okay with it, and so personally, he didn't want to be part of it.
And that was the point at which OceanGate ceased the engineering
With Pete.
with Pete.
Yep.
Were you involved in the carbon fiber hull winding process?
I watched the whole thing. That's it. So in the process itself, you're talking about the physical
Correct.
build of it?
Yes.
Yeah, so I set up GoPro cameras and watched most of it. I think it took a month, so 4 or 6 weeks or something like that. It was a long time. But I went and watched it. We were watching for, we were just watching for bad behavior. Is it more than anything? Not that we didn't trust them, just carbon fiber structures are really all about process, and you want to make sure that the process is done well, so we wanted to watch that.
Did you ever visit Spencer Composites, and what was your technical opinion of the facilities and processes which you
Oh, a lot, yeah. Well, technical opinion, Brian's done a lot of neat stuff. He's built a lot of, and he prides himself on doing the one-offs, for sure. Facility-wise, it's a bit dirty for me. I guess it wasn't for him, but it was a little bit of a concern of ours. Thought, well, let's just let's just make sure that nobody's, blowing the leaf blower around here because of all this dust while they're winding it. It definitely wasn't aviation grade, clean facility, for sure.
And as the director of engineering, did you make all engineering decisions?
No.
Did you make any engineering decisions?
Yes.
And who would make the majority of the engineering decisions?
It was Stockton, for sure. And so my job as the director of engineering is more about rounding up the cattle than it is about making all the choices, for sure. Showing the leadership to the younger people that are coming in, but then maybe to raise the technical questions when it's appropriate and go do that research. If I could control it, or if I did control it, it was a significant problem or a significant issue, which maybe we'll talk about. That's how 18 strain gauges got on the hull. I wasn't going to settle for anything else. So an engineering decision like that, I made it. And Stockton and I argued about it a lot. But pretty much, if the technical decision let's say the technical decisions for the case itself, the carbon fiber structure, as Brian Spencer. I could raise the alarms all I want, but it's Brian Spencer, look at Stockton, and he'd say, this is what we got. This is what we're going with. To the extent that I wasn't comfortable really with the fact that we weren't going to have witness panels. I couldn't understand that about Brian. Like, how would you build this without a witness panel? That's so basic. Seems so basic. But I couldn't stop that. To get the witness panels, the manual was already done, and Stockton wanted to go with that. So this is just a couple of examples of how I could influence it in some things that, if it mattered enough, then I'd fight for it. And if it didn't matter enough, I'd find a way I can mitigate it.
And was that Mr. Rush's management technique just to you, or was that employed throughout others that you witnessed at OceanGate?
He would fight for what he wanted. And what he wanted, even if it changed from day to day, right? Like he would fight for what he wanted, and he wouldn't give an inch much at all. So the fights that I had with Stockton, most of it behind closed doors, because as the director of engineering, let's keep continuity in the crew. And they can't really know that the two people on top are in solid disagreement. Most people would just eventually back down from Stockton. Like it was almost death by 1,000 cuts in most of the things.
You had mentioned witness panels. Can you briefly explain what a witness panel is for the record?
Right, so witness panel, if you were to, what was the whole, like 8 feet or something, if you're gonna make an 8-foot carbon fiber structure like this, make 2 extra feet. Cut those off. Keep those in a vault or someplace temperature controlled, humidity controlled, and wrap them up. So if you have a problem, you can go back to what it was. You can do mechanical testing on it. You can do chemical testing on it. You can send it to where you need to go. But if, like in the case where we're sitting here today, somebody's going to try to come up with a reason why this thing imploded, serial number 2 now, without a way to know how it was built. It's, in these types of systems, that's a pretty important thing to do.
Did you make that recommendation?
100%. 100%.
And it was denied by?
Brian Spencer in Stockton. The mandrel was already built and the size was already committed. So when I came into the program, that was done. They already had a plan to go forward with it. David Lockridge's complaint, I think in one of the complaints was you can see light through the end. Well, that's because there's the 3 inches. If you could see light, I mean, there's discussion to happen around that, but let's suppose that you could. That's the 3 inches that was supposed to be cut off. Witness panel would have been the one to measure that, and Brian Stockton didn't want to do it. Stockton, I think for that one, Stockton was more open to it. I think he was already, it was already on course to get done, right? I came into the program for sail number 1, and they had already, the size was committed, Mandrel was already committed and built, Brian Spencer already had his path. Items like that, and the fact that maybe we shouldn't cast titanium domes and put this in deep sea pressure because of the void concentration, Stockton really didn't know and understand at the time. And for a while there was probably a honeymoon phase with Stockton and I for a while, because it kind of blew his mind. He actually told me one day over lunch, he's like, "Thank God you were here."
And what about testing? Was any testing conducted on the first Titan hull?
So mechanical testing really wasn't something that we could do on it. Acoustic testing, we wanted to do on it, and we tried. We had some experts come and take a look at the parts that were cut off and try to get through the hull. We went and saw Boeing acoustic experts and said, how can we go do this and go find whether or not we have voids in there? And Stockton and I were concerned about a void in an interstitial void, or which could either be a delam, a full delamination, or not. So when I say a void, there's going to be microvoids in there. Let me back up and say, when I'm talking void at this scale, it's a large scale void. It's a intralayer delamination. So we were concerned about that because of what we saw in the 1/3 scale, and so we reached out to Boeing and went down there and talked to them, like, how can we get a good measurement? At 5 inches thick, you really start to lose your ability to do that well. Two types of acoustic emissions, which maybe we'll talk about later, right? We had some experts look at it, and we didn't yield results that we could do much with.
At what point did you know that the submersible is not going to be classed or adhere to structural
That's a
standards of the
good-
class society?
Right, that's a good question. I don't know when we took this divergence. So the divergences were, I don't remember there being a defined day that, hey, we're going to try to get it classed here, and then we're going to go off this way. It was probably the summer of 2016. It was probably about the time we had to make the decision to go from grade 5 to grade 3 titanium. But there was no discussion ever of now getting classed, and it was a further divergence from their involvement.
And with regard to the classification society, so discussing the classification society and the carbon fiber structure, was that the major issue with not being able to go classed?
I think it was part of the issue. Stockton's first issue was time and cost, like to go through their plan, and I think he really wanted them to be part of it. But I think the plan that they came up with, if I remember right, one of the days he was crying on my shoulder. It's going to take too long and way too expensive. It's ridiculous. And in his words, it stifles innovation. I said, well, you could still be innovative. It might take a little bit longer, but there was a divorcing, so to speak, over the idea when he couldn't get traction on what he wanted.
So the classification society provides, as you stated earlier, will provide oversight, consistent testing, retesting, which would, in anybody's eyes, you're looking at extended safety, right? So if it's not being classed because it takes too much time, it's too expensive. So in your mind, are you saying that you're giving up a little bit on safety to take away from the cost?
Classing, I don't think classing would have prevented this accident. And certification, my comment earlier holds, right? I mean, aircraft are certificated, and we still lose them. So that by itself, just by itself, I want to be careful in how I answer this, right? Because that is not going to prevent 100%. We absolutely could. We could we could 100%, engineering-wise, prevent all traffic accident deaths. 100%. We would all be giving up a lot of convenience to do that. Right? So the idea that we go through this certification or and this classification, it gives us a path to get there with good confidence that we're going to be successful, but certainly it doesn't prevent things like that. But that's with let's say classing of vessels and whatnot. There's other guidance that we look at, like ASME, right, that you want to follow, and engineers should follow. And I have some stuff that we could talk about. And so we followed the guidance that engineers would follow for solid development. And in fact, the analyst that I hired was a Boeing. I chose an aviation analyst to do the FEA models for that reason, so that we could follow like ASME guidance and put more of an aviation type discipline and standard into the development of what we're going to go build.
You had mentioned David Lockridge previous.
Yeah.
Were you involved in creating his inspection report?
No, I didn't know that he was doing it. So we asked David to do, we needed, so when serial number 1 was complete, we needed a handoff to operations. And that's a very standard thing to do in large companies. Eventually, the technical department has to not handle this anymore. And so we told David, I said, hey, from an operations perspective, like, tell us, what are we missing? Like, what do you need? David was the perfect subpilot for this. He was great. I really wish the news would get his relationship with engineering correct. We depended on him to know that things were right from an operational point of view. And that's the report that we wanted to know. Like, is there something that we could go help with to do? The report that he came back with, I was surprised by. I'm not shocked in the sense that I understand why he wrote it, and I understand the difficulties that he had in communicating his wishes through Stockton, and I understand why.
Were you at the meeting where he himself and Mr. Stockton had discussed the findings?
I was, and we could probably call it, in air quotes, the meeting, and it's the one where eventually he was let go, right?
Do you know if the board of directors was informed of Mr. Lockridge's inspection findings?
No, no, and that's really both a personal and professional point of contention with me. I mean, I stopped the 2019 Titanic dive because the data, the instrumentation that I put on it wasn't good, and I was fired for it. And what I got from Stockton is the board said that you should have known this was happening. And I said, well, let me point you to exhibits A, B, C, and D that I've been telling you. Like, why aren't we telling the board? So I don't know that, I don't think Stockton communicated to the board with those things, but I mean, if I'm not sitting in the meeting, I wouldn't know.
So in the spring of 2018, the Titan was then shipped or taken to the Bahamas to conduct testing.
Yep.
Were you there for any of the testing initially?
Can I answer this with both yes and unfortunately? I was there.
Care to expound?
So once the engineering team turns something over, right, you're done. We've shown that it works. The systems work. You communicate how to take care of it, and then you field the issues that come in. And in my roles in the past, we would call these things MRB, material review boards, right? So you'd have a nonconformance or something where an engineer has to go answer it. We'd have to provide the disposition for it. And that's the phase that we should have gone to. And quite honestly, I didn't have a desire to go step foot in the Bahamas. I didn't want to be, the operations group was not was not a fun place for me to work, and I didn't want to be there.
But there was a planned expedition in June to July of 2018, is that correct?
Oh, there was, yeah, right. So I wrote the qual plan for it. The first time we put it in the water, I dropped it on a fishing line, 200-pound strength deep sea fishing line, because I could calculate the buoyancy. I was 150 pounds negative, and we started with that. And I wrote a series of plans for them to go do this, and I wanted to see the data to buy off on the idea and whether or not we were seeing what we expected to see.
How did you confirm the depth at which the hull would have reached?
We had an acoustic transmission on board, so same thing that we saw here that communicates to the top, and there's a way to ping items underwater and sends you a return on the depth, whatever it is, and so we have these systems on there.
We've been discussing a document that's going to be introduced as an exhibit. This document is relevant to the investigation, in my opinion, and however, the PIIs and the board have not been able to review it previously. So in that instance, Mr. Nissen, if you would just speak to the document's contents, but not to the any other parties that were aware of this document, or maybe who you briefed it to, I'd appreciate that, sir.
So this one's just it's a quick look. After we closed out, or started to close out some 4-kilometer data. And what I wanted to communicate really to the team was that it's moving more than we thought. And so Brian Spencer's design and analysis report, section 6.3, second paragraph, the DAR predicts failure to be hoop failure on the inner surface at the center of the cylinder at about 2.21 times the design pressure. That turns out, actually, if we get to it, to be the basis for the FEA models that we produced. It's really that quote in there. And so I write comparing some measured strain and extrapolate 4-kilometer data. The DAR, which was 2.21 times the design pressure, was considered to be conservative, and we were deflecting about 37% higher than prediction, which is really important because the design basis for it was to constrain the movement at the center of the case. Like, it couldn't move beyond a boundary. And I think in here, we talk about hull deflections in here, where I think it's figure 11. We wanted to be at figure 11. Through membrane stress, a 19.8 KSI, to ASME was a 1.84 factor. To yield, it was a 2.76. So even the domes, the titanium pieces, which I communicated to the group, it's a match set. So the modulus has to be the same, and that modulus was limited by Brian's design and analysis report at 2.21 times the operating pressure. Once he limited that and gave me the modulus for it, then all the rest of the design was based on that. And so it's significant for the April, to understand what happened in April. We hadn't really gone deep enough, long enough, and we were flexing 37% more. So it was the first warning.
And when was this report drafted?
I released it October 10th, 2018.
And from when you released that report until 2019, were any corrections or modifications made to the carbon fiber hull?
No, Brian said it was fine. And really to modify that, well, let me back up. Eventually you scrap the hull. which we did.
Recorder, can you please bring up Exhibit 073? And in the fourth paragraph, it states, "The dive, which was validated by a representative from Lloyd's Register." And this was the April 19th, 2019 dive in the Bahamas.
April 2019?
2019.
Right.
Did you have any communications with this validator from Lloyd's Register?
No, the whole classing, like all that validation was Stockton. I wasn't allowed to be in that. I really wasn't allowed to be in operations unless something went wrong. That's it. No, I'm sorry. I'm sorry to chuckle about it, but it brings back some memories is all. Sorry.
Do you know why they would say that the dive was validated by a representative from Lloyd's Register?
That was Stockton's doing. I didn't validate it. No, in April 2019, that told me you can't go to the Titanic, like it killed it.
In April of 2019, this was the dive where there was four crew members, including Mr. Rush.
Mm-hmm.
And they went down to 3,760 meters.
Yeah.
Was there a representative from Lloyd's Register there in the Bahamas that you're aware of?
I think so. Like I remember vaguely. I'm not even sure I was there for that dive, but all that talk, as when serial number 1 was built, Stockton had a vehicle, and Tony became less and less important, and I had less and less input. Right? So I didn't know.
So subsequent to this dive, in June of 2019, an OceanGate pilot was conducting a pre-dive inspection and identified a crack in the carbon fiber. When were you made aware of this identification, and what were your steps taken?
Right. We have to back up a little bit to December 2018. In December 2018, Stockton wanted to be done with coal dives, and it made it. What's not talked about a lot is what we're about to talk about right now. Serial number 1, for all practical purposes, was a successful program. And what I'm about to tell you is why. In December 2018, when Qual wanted to be done, when we wanted to be done with Qual, and Stockton could then load it up and send it to, when I say it, send Titan to Newfoundland. Sure, it met all the operational objectives, but we still needed to look at the data a little bit, and part of the discipline that I would put in it is I would still look at the data and tell them whether or not we can continue on. So we had a meeting in the winter, spring of 2019. He wanted to go to the Titanic, and I came to him with the acoustic data and strain and set up a meeting and said it's not clean. Like, we still can't do it. There's something going on. And an extension of this report here, I showed him the pictures I have of the AE data that showed something's going on in the center of the case. Something's going on in the left side of the case. You need more dives, and I can't. It was the maddest I've seen Stockton, for sure. So they went and conducted another dive, and I wanted a few more clean, but that turned out not to be clean. So the data from that I don't remember that data had totally come back ready to go, but I got a picture. I said, I think the email was, "Hey, Tony, is this supposed to be there?" I said, "Nope, that's a crack. Like, the hull's done." So I left my desk and I went to Bob Schumann, and he was the CEO at the time. And I said, "Titan's got a crack in it." I said, "The hull's done." Then I spent a couple hours trying to convince people that, no, this is not salvageable. And I was on a plane, I think the next day, with a couple of other folks down to the Bahamas to go take a look at it. And we started carving it out and noticed that the crack was bigger than we thought, just by the picture. So it was subsurface.
And so for the pilot to conduct the inspection, so just so we covered, the external portion of the carbon fiber hull was covered in a polyurethane coating,
That's right.
which is similar to a lining that is used in a truck bed.
Like a soft rhino lining.
So on the external portion of the hull, how much of the hull, of the carbon fiber hull, is visible? If I'm looking at it from the outside.
From the outside?
Yeah.
None.
Okay.
0.
So on the internals, there is an insert.
There is.
And what was the approximate gap between the insert and the inside of the carbon fiber hull?
Maybe 3/4 of an inch.
Okay.
Not a lot. Let's say 3/4 plus or minus quarter.
I'm going to, the recorder, if you could please bring up Exhibit 091, which is Titan Systems Images, and scroll to page 8. And I'm going to call your attention to the bottom left picture. Or the left picture in this case. So can you explain to me what you see in that picture?
The left one?
Yes, sir.
All right, so, so that's a view. If the front dome was open, it's just a view forward, looking aft. You see the back wall there with the monitor subfloor, and then you can kind of see a gap, a ring, and that would be the insert and the gap to the hull there.
Okay. And so that gap is, so the outside of that gap is the inside diameter of the carbon fiber hull, correct?
Yes. No. So the titanium takes up, for the most part, the titanium takes up a little bit, and there's a flare that goes in. So the actual, it widens a little bit as you get back there. So I want to be careful.
Okay.
Yeah. For all practical purposes, that is the idea, though.
So how much of the hull is actually visible for inspection from a pilot as was identified?
Just the front. So the point of the insert, the two points of the insert. One, you could take the insert out and you can put an insert in for researchers. You can take that one out and you can build one for sightseers. You could take that out and you can put it in, something else. You can build the insert for whatever person's going in there. And then the second thing is you pull the insert out and then you do the inspection on the inside. So to inspect the entire surface of that hull, the operations group needs to pull that out.
Okay. So with the insert in the Titan hull, how much of the hull is actually available for visual inspection?
Oh, it's just a few inches of the front.
So a few inches of the entire carbon fiber hull is available?
Going forward to aft?
Yes.
Yes.
Any other area of the hull available for visual inspection?
But not without a camera. So a pen camera would be next appropriate to go in there. But no, if you get to the aft portion of it, I'm assuming. So we're talking serial 1 here. I'm assuming
Yes.
that serial 2 is close enough to go do that and close to the same. That I don't even know if they used an insert in it, but for ours. The aft lip, you could see it the same way.
Okay. So once the crack was identified, and you had gone out to the Bahamas,
Yeah.
and you confirmed that there was a crack, what was your communications back with Mr. Rush?
I told him the hull's done. That's it.
And what were your next steps at that point?
Put together a presentation for Brian Spencer. To help us understand this. Like, how did this happen? And, yeah.
And so to the best of your knowledge, there was a Titanic expedition scheduled for July of 2019, correct? So at that point, as the director of engineering, was your recommendation to cancel the
I killed it.
expedition?
I wouldn't sign off on it. So I got terminated.
Recorder, I'm going to ask you to please bring up Exhibit 54, which was the Titanic Survey Expedition Update.
Okay.
It was from the Strategic Director of OceanGate Operations. Sent a letter to mission specialists stating that the reason for the cancellation of the 2019 Titanic expedition was due to the loss of the support vessel.
Right.
Were you aware that this was the case that was being told to the mission specialists?
I am.
Was there any plan to tell them that there was there a hull available for the 2019 expedition?
No, that was Neil, Stockton, and Joel. I think Joel. Yeah, Joel is still there. Yeah. No, The business part of that, no, I know it went on, and I'm glad my office was in another section of the building, but it wasn't true. We didn't have a hall.
At any time, did OceanGate divulge that there was not a hall available?
That I don't know. I just know that this one I told him he couldn't use.
Did they discuss with you that the plan was to put out the message that it was the loss of the support vessel?
There was no discussion. Operations and marketing, no discussion with engineering. I just happened to be there, and sometimes I would be happy to get up and walk away.
Were you aware, or did you have knowledge of that this was discussed with the board of directors?
That I don't know. So I presented engineering section and status to the board of directors, and I was in for that, and I was out afterwards.
And why did you depart the company?
Got fired.
When did you get fired?
June 2019, because I wouldn't let him go to the Titanic. Allegedly, what Stockton tells me, he invited me to lunch and told me that Mike Ferlotti and one other board member told him that I should have known that the hull was compromised and it wouldn't work, and either he or I had to go, and Stockton said, it's not going to be me.
Thank you, Mr. Nissen. Mr. Newbar, I have no more further questions.
That concludes the first half of Tony Nissen's interview. I found it very insightful, especially regarding the building and testing of Titan, and the operational style of OceanGate itself. I find it odd that a company would hire a director of engineering and not divulge the aspiration of the company to him, that being the Titanic expeditions. And this seems almost a theme that runs throughout the testimony, that being a very distinct sense of secrecy, from those at the top to those working in OceanGate's various departments. I think it's important to note that Nissen's testimony is based on Serial 1 of the Titan, which he worked on, not Serial 2, which came after he left the company. It appears that much, if not most of Serial 1 was carried over to Serial 2, despite Nissen's previous concerns, including the crack that happened to the first hull during the testing in the Bahamas. Before being fired because of the failing of the hull, Nissen's words really do paint a vivid picture of his working conditions. It appears there was a lot of friction between departments, as well as between himself and Stockton Rush, who he describes as unwilling to budge and who wanted what he wanted no matter what. It's also stated that he, Nissen, was not responsible for various engineering decisions despite being the head of engineering. Again, this is linked to Stockton Rush, who would make many calls and would only consult Nissen when a large problem arose. From an outside perspective, this is certainly not an ideal situation in a company where the product they are designing and making requires open communication and combined effort from all departments. The lack of classification of the Titan has always been a huge issue, ever since the tragedy made the headlines. As Mr. Nissen states, there was no real discussion on the classification taking place, no scheduled plan for it, and the few times that Stockton Rush attempted it, the attempts were described as being met with dead ends. I think this speaks loudly about the fact that Titan was never going to meet regulations, and that it was known, with Titan openly described as an experimental sub, and Mr. Rush's now famous words of safety stifles innovation. Witness panels were something I was not aware of before making this video, and after learning about them, it seems a necessary part of a project like this, though, as stated, the parts for Titan were already in place, and for Nissen it was simply a put together kind of job. This I also see as a failure, that being not having the head of engineering be there for any input on the design. Much has been said about the application of the carbon fibre by Spencer Composites, and the environment in which it happened, as well as the documentation provided by the manufacturer with the calculations for the hull, which is stated to have been the basis for the build in general. This testimony raises numerous red flags, and the second half, which will be released in a future video, delves deeper into Titan's build, failings, and eventual implosion. What we do know for sure is that OceanGate parted ways with numerous employees and the testing company that they were working with during the Titan build. And for such a small company, this does not speak of a tight-knit team, but rather one that is volatile. I look forward to covering further testimonies in future videos and gaining a clearer picture of events with each one. I promise to do my very best with my videos to bring you the same. So until that next video, thank you very much for clicking on this video, and please be sure to check out my channel for more OceanGate videos, and subscribe for future content. Until next time, thank you for watching.